one really interesting example of compound exponential growth is compound interest. So a bank really likes to get their money's worth when they're charging interest. So for example here, we're going to say that we take out a $5,000 loan. And we have interest on loans. They charge you a certain percent per year to basically borrow the money. And so we're going to say that it has an interest rate of 4%. And we're going to see after 5 years how much that's going to be worth. So you could think of this as the A. You could think of this as the 1 plus B part, and this is the time. Okay? So we're going to set up our model. It'd be $5,000. And we're going to do 1 plus 0.04 for our rate, our B. And for x here, we can actually just plop in 5 here. So this is going to be, when I crunch this in my calculator, $6,083.26, rounding to 26 cents. So $1,083.26 are going to be charged for you to keep this loan for 5 years. Okay, and it's called compound because after the first year, let's start over with the 5,000 here. After the first year of 4%, 4% of 5,000 is $200. So they add that onto the bill, but then when they look at the next year, they're going to charge 4% again. So now we're looking at 4% of 5,200, which is slightly more, 208. Okay, so they got that extra $8 because they get that extra 8 from charging interest on the interest. And again, if we do this with 5,408, 4% would then be 216.32. So it's called compounded because it keeps compounding on itself. You get interest on interest on interest. Okay, and so it gets a little better than this for bankers. So we're going to do an example with the same amount of money. We're going to start with $5,000. We're going to have 4% interest. And we are going to do something called compounding within the year. So we're going to compound first semi-annually. So what this means is we're going to start with this $5,000. And normally, we would have these 2 years where we would charge 4%. We would have the 5,200, and then we would charge 4% again, and then we would charge, what was it? 5,408 total? Okay. So now that was the old way. Now semi-annually, what it actually does, they chop it up into semi-annual segments here. And they can't charge you 4% every half a year because that would be charging you twice as often as they used to. So what they do is they take the interest rate and chop it in half too. They chop the year in half, so they chop the interest in half. But because they chop the interest in half, they are then allowed to charge interest twice as often. So in this case, we are actually doing 5,000. And we're doing 1 plus, and I'm going to write it this way. They're going to take the 4%, and before they add it, they chop it in half to get the 2%. And normally we would go for 2 years, but it's going to be 2 times 2 years because we're doing twice every year. Now, if we work this out on our calculator, 5,000, I'm getting an answer of 5,412.16. Now this is slightly more than what we talked about in the second year. I'm sliding up here because in the second year we had 5,408 without doing this halfway through the year compounding. But now we've got an extra $4 because they charge that half rate twice as often. And so this is what's called compounding interest. Now the banks want to get even more money, so we're going to compound monthly. Okay, so the idea is the same thing. We're going to have 5,000 to start with, and we're still going to have 2 years, the same period of time, so I probably should have written that up there. But instead of chopping up each year into halves like we did up here, we're going to be chopping this up into 12 different months. So what used to be 4% is now going to be 0.04 divided by 12. And we're going to do that both years. So we'll take the 5,000, and we're going to use a 0.04 rate that's been chopped up in 12, which, by the way, if you're interested, that's a rate of 0.3%. But we're going to do it per month. So instead of doing this 2 years, we're going to do this 12 times the 2 years. Because we're chopping the rate into 12s, but we get to do it 12 times as often. And I'm just working this out on a calculator now. The answer, when I do it monthly, is 5,415.71. So the increase now is $3, almost $4, over doing it semi-annually. So you're probably thinking, well, why don't we do this weekly, or why don't we do this every day? And the answer is, as far as like student loans go, I know that they compound interest daily in this way. At least my loans were through Wells Fargo. And so they actually stop at daily, though. They don't do it like hourly or minutely or secondly, because at daily they get kind of the best return. If they try to do more, it actually costs more to just do more calculations. And so let me give you the formula for compound interest. The total is going to be alright, so I'll write these different parts here. This is the total. This is called the principal. This is what I always mix up the spelling here. The principal is what you started taking out, or what you put in a savings account. It's the beginning amount. This is your rate, your interest rate. K here and here, it's in there twice, is the number of compounds. And then the T here is time. Now just for compounds, when you do it semi-annually, you're going to have K equal to 2. If you do it monthly, you're going to have it be 12. Sometimes they do it quarterly. That would be 4 times a year. If it's daily, then it's going to be 365. Weekly would be 52. And there's a lot more. You could figure out how many hours are in the year and how many minutes are in the year. So just keep track of per year, how many times is it going to be compounded. And so this formula is nice, so you don't have to think through it every single time like we were doing before. If we have $1,000 and we have a 3% interest compounded daily for 4 years, this is what we would do. Total, put the principal, we do 1 plus 0.03 all over 365. 365 times 4. and we'd crunch that on your calculator. Now if I were you, I would double check with what I get here, because putting this in the calculator can be very tricky. So you want to make sure that you're putting parentheses around, like some calculators, you want to put parentheses around this fraction here when you put it in, and you also want parentheses around this. So there are these chunks that you want to make sure you have parentheses around. I'm getting 1127.49. So you should make sure that you're getting that number too.